Hello, viewers of AraaTech. Today, once again, presenting a very interesting and informative topic. It calls Turing Test and Artificial Intelligence. Let me explain it in an easy way for your easy understanding. Imagine you are chatting with someone online and you cannot see them. Now, there is another participant in the conversation who you also can't see. One of them is a person and the other is a computer. If you can't tell which is which based on their responses, that computer has passed the Turing test. It means it can talk and behave so much like a human that you cannot tell the difference. It's like having a chat with a friend, and if you can't tell whether it's a human or computer, that computer is pretty smart. Let's go deep in the theory. Thanks. So now we will start our journey about Turing test and AI. Unmasking the digital masquerade and delving into the depths of artificial intelligence and philosophy. Introduction. The metaphor of a virtual masquerade ball serves as an evocative image to illustrate the essence of the Turing test. In this analogy, humans and machines participate in a social setting, much like a ballroom, where they interact through written text, and crucially, their true identities are concealed. This encapsulates the central idea of the Turing test, which was conceptualized by the renowned mathematician and computer scientist Alan Turing in 1950. In essence, the Turing test is a thought experiment designed to assess the capability of a machine to exhibit intelligent behavior indistinguishable from that of a human. The scenario involves a human interrogator who communicates via text with two concealed entities, one human and one machine. The interrogator's task is to discern, based solely on the text-based communication, which participant is human and which is the machine. As technology has advanced over the years, particularly in the field of artificial intelligence, the relevance and implications of the Turing test have become subjects of ongoing and intense debate. The initial allure of the Turing test was rooted in its potential to provide a benchmark for determining which a machine could be considered intelligent. However, with the evolution of artificial intelligence technologies, critics have raised questions about the test's limitations and its ability to truly measure intelligence. This exploration seeks to peel back the layers of the Turing test, delving into its complexities. It aims to uncover the nuances of the test, acknowledging its strengths and weaknesses, and to examine its enduring impact on two major fronts: AI research and the philosophy of the mind. In the realm of AI research, the Turing test has influenced the direction of studies and experiments, shaping the early landscape of artificial intelligence. It served as a catalyst motivating researchers to pursue the ambitious goal of creating machines that could not only perform specific tasks but also engage in conversations indistinguishable from those of humans. Simultaneously, the Turing test has sparked profound philosophical discussions about the nature of intelligence and consciousness. By raising questions about the ability of machines to replicate human-like behavior, it has prompted contemplation on what it truly means to possess intelligence and consciousness. These philosophical explorations extend to considerations of the ethical implications of creating machines that might exhibit behaviors resembling human cognition. As artificial intelligence continues to evolve, the exploration posits that the Turing test may no longer be the sole or ultimate measure of machine intelligence. Instead, contemporary artificial intelligence research places a greater emphasis on developing specialized systems that excel in specific tasks, such as image recognition or language translation. This shift in focus reflects a broader understanding that intelligence is multifaceted and cannot be encapsulated by a single test or criterion. In conclusion, the metaphorical masquerade ball of the Turing test, where identities are hidden behind the curtain of text, captures the essence of a pivotal concept in artificial intelligence. As we revisit this test, it becomes clear that its historical significance and philosophical implications endure. Even as the landscape of artificial intelligence research evolves, the exploration invites us to reflect on the profound questions raised by the Turing test and to consider new avenues for assessing the capabilities of artificial intelligence in our ever advancing technological landscape. After that definition and a little bit explanation, now we will go in detail what is the original Turing test. It's the same definition, explanation, but in a different way. The original Turing test. In the basic setup of the Turing test, a human interrogator engages in text-based communication with two concealed entities, one human and one machine. The central objective of the interaction is for the interrogator to determine solely through the exchange of text messages which participant is the human and which is the machine. The scenario places a significant emphasis on the ability of the machine to generate responses that are indistinguishable from those of a human counterpart. The interrogator, who is unaware of the true identities of the participants, must rely solely on the content and style of the textual responses to make an accurate determination. The test is structured in such a way that the machine and human respond to the interrogator's queries or prompts, aiming to convince the interrogator that they are the human. If the machine successfully mimics human-like communication to the extent that the interrogator cannot reliably differentiate between the two, the machine is considered to have passed the Turing test. This passing of the test implies a level of artificial intelligence that mirrors human intelligence, at least in the context of text-based conversation. The simplicity and elegance of this setup underscore Turing's fundamental idea: if a machine can emulate human conversational abilities to the point when an external observer cannot consistently distinguish between human and machine responses, then that machine demonstrates a form of intelligence comparable to human intelligence in this specific domain. This emphasis on natural language understanding and generation has made the Turing test a foundational concept in the field of artificial intelligence, influencing subsequent research and discussions about machine intelligence and human-computer interaction. In the context of the Turing test, the passing criteria are straightforward. Success is declared if the interrogator cannot reliably distinguish the machine from the human. This outcome signifies that the machine has demonstrated a level of intelligence that is indistinguishable from human cognition, at least within the scope of the text-based conversation. The essence of the passing criteria is rooted in the idea that if the machine can consistently produce responses that are so human-like that an interrogator, relying solely on the text-based interaction, cannot accurately determine which participant is the machine and which is the human, then the machine has effectively passed the test. The declaration of success implies that the machine has achieved a notable milestone in artificial intelligence. It has demonstrated the ability to engage natural language communication to a degree where it mirrors the intricacies of human conversation. The passing of the Turing test suggests that at least in this specific context, the machine's intelligence is on par with human intelligence as discerned through textual interaction. It's important to note that passing the Turing test, while a significant achievement, does not necessarily imply a comprehensive understanding of all aspects of human intelligence. Critics have argued that the test might assess the machine's ability to imitate human conversation rather than truly understand or possess intelligence in the same nuanced way humans do. This distinction underscored the ongoing debates surrounding the limitations and implications of the Turing test in evaluating the depth and nature of artificial intelligence. The debate surrounding intelligence versus imitation constitutes a key issue in discussions about the Turing test. Critics argue that successfully passing the Turing test does not necessarily indicate genuine intelligence in machines, but rather demonstrates their capacity to mimic human conversation effectively. Imitation as a measure. Opponents of the Turing test as a definitive measure of intelligence often assert that the test primarily evaluates the machine's ability to replicate human-like responses in a conversational context. Success in the test may be achieved by employing sophisticated algorithms and language models that generate contextually appropriate and human-like text without necessarily understanding the underlying meaning. Lack of understanding. Critics contend that passing the Turing test does not guarantee that the machine comprehends the content of its responses or possesses true understanding, consciousness, or self-awareness. The argument is that machine might excel at mimicking conversation by relying on patterns and statistical associations present in the training data without having a deeper grasp of the concepts being discussed. Surface level imitation. The focus on textual interaction in the Turing test is seen by some as emphasizing surface level imitation rather than delving into the intricacies of human thought processes and comprehension. Successful imitation, in this view, might involve generating responses that superficially resemble human language without a genuine understanding of the context or underlying concepts. Inherent limitations. Some critics believe that the Turing test sets a somewhat narrow criterion for intelligence, emphasizing linguistic prowess and conversational skills while potentially overlooking other facets of intelligence such as problem solving, creativity, or emotional intelligence. Advancements in natural language processing. As natural language processing technologies have advanced, critics argue that machine can become increasingly adept at imitating human conversation, making it more challenging for the Turing test alone to serve as a reliable indicator of true machine intelligence. Ethical implications. The focus on imitation raises ethical concerns as it prompts questions about the responsibility of developers and the potential for creating systems that deceive users into perceiving a level of intelligence that may not align with the machine's actual understanding or awareness. In summary, the intelligence versus imitation debate within the context of the Turing test underscores the nuanced challenges in assessing the depth and authenticity of machine intelligence. It encourages a broader consideration of what constitutes genuine intelligence beyond the ability to replicate human-like interactions. Surface level convincing. Advanced chatbots equipped with natural language processing capabilities can engage in conversation that, on the surface, appear remarkably convincing. They may respond, contextually use colloquial language, and adapt to the user's conversational style, creating an illusion of genuine understanding and intelligence. Scripted responses. Critics argue that in many cases, chatbots rely on scripted responses and redefined patterns learned from vast datasets rather than true comprehension or reasoning. The concern is that the appearance of intelligence may be a result of statistical mimicry rather than a genuine grasp of the content being discussed. Limited contextual understanding. While chatbots may excel in short and narrowly focused conversations, doubts arise when considering their ability to maintain a coherent and meaningful dialogue over more extended or diverse interactions. Questions persist about their capacity to truly understand the broader context of a conversation and engage in nuanced discussions. Deceptive user perception. The success of chatbots in simulating human like conversation raises ethical questions about potentially deceiving users who may attribute a higher level of intelligence to the machine than it actually possesses. This creates a potential for misunderstanding the true capabilities of artificial intelligence systems and their limitations. Ethical implications. Deceptive practices in human machine interactions have ethical implications, especially when users are led to believe they are communicating with an intelligent entity capable of genuine understanding. Transparency becomes a critical concern, emphasizing the need for developers to communicate the limitations of chatbots and the extent of their actual intelligence. Progress in natural language generation. As natural language generation models continue to advance, chatbots may become even more proficient at generating contextually relevant responses, amplifying concerns about the potential for deceit. User trust and expectations. The success of chatbots in creating convincing interactions underscores the importance of managing user expectations and fostering trust. Misleading users about the true capabilities of artificial intelligence systems can erode trust in the long run. In summary, the issue of chatbots and deceit highlights the fine line between the impressive conversational abilities of artificial intelligence systems and the potential for users to misinterpret the nature of these interactions. It emphasizes the need for transparency, responsible development practices, and ongoing scrutiny of the ethical implications surrounding the use of chatbots and similar artificial intelligence technologies in human communication. The Chinese room argument, introduced by philosopher John Searle, provides a thought provoking critique of the idea that mere symbol manipulation, a strength of computers, can result in genuine understanding. This argument serves as a significant component of the broader debate on artificial intelligence and the limits of machine cognition. Thought experiment. Searle's argument is presented through a thought experiment involving a person in a room who does not understand Chinese but has a set of rules for manipulating Chinese symbols. The person receives Chinese input, follows the rules to manipulate symbols, and produces appropriate Chinese output without comprehending the meaning of the symbols. Absence of understanding. The central claim is that despite the ability to manipulate symbols and generate seemingly intelligent responses in Chinese, the person in the room does not understand Chinese. Searle extends this idea to computers, arguing that their manipulation of symbols does not equate to genuine understanding, even if they produce sophisticated outputs. Syntax versus semantics. Searle distinguishes between syntax, the arrangement of symbols, and semantics, the meaning conveyed by those symbols. He argues that computers excel at syntax but lack true semantic understanding. They manipulate symbols based on rules without grasping the underlying meaning. Criticizing the Turing test. John's argument challenges the effectiveness of the Turing test as a measure of intelligence. He contends that passing the test does not necessarily imply comprehension or understanding, as demonstrated in the Chinese room scenario. Consciousness and intentionality. John emphasizes the importance of consciousness and intentionality in understanding language. He argues that computers lack subjective experience and intentionality, essential components of genuine understanding. Philosophical implications. The Chinese room argument raises profound philosophical questions about the nature of consciousness, meaning, and understanding. It challenges the reductionist view that intelligence can be entirely captured by symbol, manipulation, and prompts, reflection on the subjective, experiential aspect of cognition. Limits of symbol manipulation. John's arguments suggest that the capacity for symbol manipulation, while powerful for certain computational tasks, may fall short in capturing the richness of human understanding, which involves more than rule based processing. Alternative models of cognition. The Chinese room argument encourages exploration of alternative models of cognition that incorporate not only symbolic manipulation but also aspects of experience, consciousness, and contextual understanding. In summary, the Chinese room argument provides a compelling challenge to the notion that mere symbol manipulation, as exhibited by computers, can lead to genuine understanding. It prompts a reconsideration of the relationship between syntax and semantics, consciousness, and the complex nature of human cognition, contributing significantly to philosophical debates about the true nature of artificial intelligence and the boundaries of machine comprehension. In response to the debates and limitations associated with the Turing test, researchers have proposed alternative tests for assessing intelligence that go beyond the scope of natural language conversation. These alternative tests aim to capture different facets of cognitive abilities, problem solving skills, creativity, and adaptability. Here are key aspects of these alternative approaches. Problem solving tests. Some alternative tests focus on evaluating a machine's problem solving capabilities. This involves presenting the system with a set of problems that require logical reasoning, critical thinking, and the ability to derive solutions. Creativity assessments. Assessing creativity involves evaluating a machine's capacity to generate novel and valuable ideas, solutions, or outputs. This can encompass tasks such as creating art, composing music, or designing innovative solutions to problems. Learning and adaptability matrix. Rather than emphasizing static conversational abilities, alternative tests may center on a machine's learning capacity and adaptability. This involves exposing the system to new information or scenarios and measuring its ability to acquire knowledge and adjust its behavior accordingly. Dynamic environments. Some proposed tests create dynamic environments that require machines to navigate changing conditions. The ability to adapt to unforeseen circumstances and learn from experience becomes a crucial aspect of intelligence in such scenarios. Simulation based assessments. Simulation based tests involve placing machines in realistic or virtual environments where they must perform tasks akin to real world challenges. This approach assesses the system's ability to interact with and respond to complex, dynamic situations. Multi-model testing. Instead of relying solely on text-based interactions, alternative tests may involve multiple modalities such as images, sounds, and even physical interactions. This approach seeks to evaluate a more comprehensive set of cognitive abilities. Ethical decision-making challenges. Assessing a machine's ability to make ethical decisions is another alternative. This involves presenting the system with normal dilemmas and evaluating its capacity to make decisions that align with ethical principles or societal norms. Human-machine collaboration. Some tests focus on evaluating the collaboration between humans and machines. This involves assessing how effectively machines can complement human abilities, contributing to joint problem solving and decision making processes. Long term planning and goal setting. Intelligence is not only about immediate problem solving but also about long term planning and goal setting. Some tests may involve evaluating a machine's ability to formulate and pursue goals over extended periods, real world applications. Rather than relying on abstract scenarios, alternative tests may involve deploying artificial intelligence systems in real world applications such as healthcare, finance, or autonomous vehicles. The success of these systems in practical applied setting becomes a measure of their intelligence. By diversifying the criteria used to assess intelligence, these alternative tests seek to provide a more comprehensive understanding of machine capabilities. They acknowledge the multifaceted nature of intelligence and aim to move beyond the limitations associated with relying solely on conversational abilities as emphasized by the Turing test. The evolution of AI research beyond the Turing test has witnessed a shift in focus from the pursuit of general human level intelligence to the development of systems that excel in specific capabilities. This strategic redirection reflects a more pragmatic and nuanced approach to artificial intelligence, acknowledging the challenges associated with achieving a broad, all encompassing form of machine intelligence. Here are key aspects of this paradigm shift. Task specific expertise. Artificial intelligence research increasingly prioritizes the creation of systems that specialize in specific tasks. This approach recognizes that true artificial general intelligence, equivalent to human intelligence across diverse domains, remains an elusive goal. Specialized domains. Researchers are channeling efforts into creating artificial intelligence systems with expertise in particular domains. Examples including image recognition, natural language processing, language translation, medical diagnostics, and autonomous driving. Deep learning and neural networks. The success of deep learning and neural networks has played a pivotal role in this shift. These techniques excel in tasks involving pattern recognition, enabling the development of highly specialized models tailored to specific applications, practical applications. Artificial intelligence systems are being applied to solve real world problems in various industries. For instance, in healthcare, AI models are employed for disease diagnosis and personalized treatment recommendations. In finance, they assist in fraud detection and risk assessment. Performance metrics and benchmarks. Rather than relying on a single generalized intelligence metric like the Turing test, researchers now use specific performance metrics and benchmarks tailored to each task. This approach provides more targeted and objective evaluations of artificial intelligence capabilities. Data driven approaches. AI models are often trained on vast data sets relevant to a specific domain. This data driven approach allows machines to learn patterns and nuances specific to the task, enhancing their performance in particular applications. Transfer learning. Transfer learning techniques enable artificial intelligence models to leverage knowledge gained in one domain to improve performance in related tasks. This approach promotes efficiency in training and allows for the adaptation of models to new situations. Collaboration with human expertise. Artificial intelligence systems are designed to complement and collaborate with human expertise rather than replace it entirely. Human artificial intelligence partnership leverage the strengths of both, leading to enhanced performance in various fields. Incremental progress. The focus on specific capabilities allows for incremental progress in artificial intelligence research. Rather than waiting for a giant leap toward AGI, advancements occur through continuous refinement and specialization in individual tasks. addressing ethical and regulatory concerns. Specialized artificial intelligence systems facilitate clear ethical and regulatory frameworks. Issues related to accountability, transparency, and bias can be addressed more effectively in specific domains, contributing to responsible artificial intelligence development. In conclusion, the shift beyond the Turing test underscores a more pragmatic and application focused approach in artificial intelligence research. By concentrating on specific capabilities, researchers aim to deliver tangible and impactful results, advancing the field and addressing practical challenges in a manner that align with the current state of artificial intelligence technology. The evolution of artificial intelligence research has led to a shift in how progress is measured, particularly with a focus on specific domains. This shift is characterized by the use of benchmarks and competitions as objective metrics to assess advancements. This approach represents a departure from the broad scope of the Turing test and provides a more nuanced and quantitative evaluation of artificial intelligence capabilities in targeted applications. Here are key aspects of measuring progress in specific domains through benchmarks and competitions. Task specific evaluation. Instead of relying on a one size fits all measure like the Turing test, benchmarks and competitions are designed to evaluate artificial intelligence systems based on task specific criteria. Each benchmark is tailored to the characteristics of the domain it represents. Quantifiable metrics. Benchmarks provide quantifiable metrics for assessing artificial intelligence performance. These metrics can include accuracy, precision, recall, F1 score, and other relevant measures depending on the nature of the task. Standardized evaluation protocols. Competitions often come with standardized evaluation protocols, ensuring consistency in the assessment of different artificial intelligence models. This enables fair comparisons and facilitates the identification of state-of-the-art approaches. Diverse domains. Benchmarks and competitions cover a wide array of domains, including but not limited to image recognition, natural language processing, robotics, autonomous vehicles, and medical diagnostics. This diversity reflects the broad applications of AI technology. Dataset challenges. Many benchmarks use large and diverse datasets to evaluate AI systems. The challenges posed by these datasets mimic real-world scenarios and contribute to the robustness of AI models. Annual competitions. Some benchmarks are organized as annual competitions, encouraging researchers and practitioners to continuously improve their models. These competitions foster a dynamic environment for innovation and collaboration. Open challenges. Open challenges invite participation from a broad community, promoting transparency and inclusivity in artificial intelligence research. The sharing of methodologies and results enhances the collective understanding of effective approaches. Innovation catalyst. Competitions and benchmarks serve as catalysts for innovation by setting ambitious goals and stimulating the development of novel algorithms and techniques. They provide a platform for showcasing breakthroughs and advancements. Industry relevance. The use of benchmarks often aligns with industry needs, ensuring that progress in artificial intelligence research directly translates into solutions for real-world challenges. This connection enhances the practical applicability of artificial intelligence technologies, addressing technical concerns. By focusing on specific domains and providing clear evaluation criteria, benchmarks contribute to addressing ethical concerns associated with artificial intelligence. Transparency and accountability are emphasized in the pursuit of better performance. In summary, the adoption of benchmarks and competitions to measure progress in specific domains reflects a maturation of AI research. This approach allows for a more granular and objective evaluation of artificial intelligence capabilities, aligning with the diverse and application oriented nature of contemporary artificial intelligence development. It also fosters healthy competition, collaboration, and innovation with the AI community. The Turing test, since its proposal by Alan Turing in 1950, has played a pivotal role in catalyzing profound philosophical debates about the nature of intelligence, consciousness, and the essence of humanity. The implication of the test extend far beyond its initial purpose as a benchmark for machine intelligence, sparking discussions that delve into the fundamental aspects of cognition and what it means to be intelligent or conscious. Here are key dimensions of the philosophical debates ignited by the Turing test. Defining intelligence. The Turing test prompts a fundamental question: what is intelligence? Philosophers have grappled with defining this concept, considering whether it is solely based on problem solving ability, linguistic prowess, emotional understanding, or a combination of these and other factors. Consciousness and self awareness. Debates spurred by the Turing test extend to questions of consciousness and self awareness. Does passing the test imply a form of consciousness, or is it merely an illusion created by sophisticated mimicry? Philosophers explore the relationship between intelligence and subjective experience. Minds and machines. The Turing test raises inquiries about the nature of minds and the potential for machines to possess a mind. Philosophers explore whether machine intelligence, even if it successfully mimics human conversation, can truly be considered a mind with thoughts, intentions, and subjective experiences. Qualia and subjective experience. Discussions influenced by the Turing test delve into the realm of qualia, the subjective conscious experience of sensory perceptions. Philosophers consider whether machines can ever have qualia or if subjective experience is unique to biological entities. Ethics of creating intelligence. The Turing test prompts ethical reflections of the creation of intelligent entities. Philosophers explore the responsibilities associated with developing machines that may exhibit behaviors resembling human intelligence. Questions of ethical treatment, rights, and moral considerations come to the forefront. Anthropocentrism and bias. Philosophers critically examine the anthropocentric biases embedded in the Turing test. They question whether the criteria for intelligence are inherently human centric and whether alternative forms of intelligence, not necessarily resembling human cognition, should be acknowledged and respected. Limits of Turing test. Philosophers analyze the limitations of the Turing test in capturing the richness of human cognition. They explore whether the test's emphasis on conversation neglects essential aspects of intelligence such as emotional understanding, creativity, and moral reasoning. Nature of language and communication. The Turing test invites exploration of the nature of language and communication as integral components of intelligence. Philosophers consider whether true understanding involves more than linguistic mimicry and whether non-verbal aspects of cognition are essential. Machines, sentience, and autonomy. Philosophers contemplate the possibility of machine sentience, whether machines, through passing the Turing test or other criteria, can exhibit a form of autonomous self-directed awareness that goes beyond mere computation. Evolution of AI and human identity. The ongoing evolution of artificial intelligence prompts philosophical reflections on human identity. As machines become more intelligent, questions arise about how these advancements influence our understanding of what it means to be uniquely human. In conclusion, the Turing test as a thought experiment has transcended its role as a measure of machine intelligence. It has become a catalyst for deep philosophical inquiries into the nature of intelligence, consciousness, and the intricate tapestry of human experience. The debates it has inspired continue to shape our understanding of both the potential and limitations of artificial intelligence in the broader context of philosophy and humanity. The enduring significance of the Turing test lies in its profound historical impact on the field of artificial intelligence. Introduced by Alan Turing in 1950, the test has left an indelible mark, serving as a catalyst for scientific inquiry and motivating generations of researchers to explore the possibilities and challenges of creating intelligent machines. Here are key aspects of the enduring significance of the Turing test. Foundational influence. The Turing test laid the foundation for early artificial intelligence research by proposing a method to assess machine intelligence. Turing's visionary idea ignited enthusiasm among scientists, providing a clear goal and direction for the emerging field quest for intelligent machines. The test inspired a generation of scientists to embark on a quest to create machines that could exhibit human like intelligence. Researchers were motivated by the challenge of meeting the criteria set forth by the Turing test, pushing the boundaries of what was considered achievable in the realm of artificial intelligence. Benchmark for progress. The Turing test served as a benchmark against which progress in artificial intelligence could be measured. Researchers aimed to develop systems that could perform at a level where their responses in natural language conversation were indistinguishable from those of humans, driving innovation and advancements in the field. Motivation for innovation. The challenge posed by the Turing test became a driving force for innovation. It encouraged the development of NLP algorithms, machine learning techniques, and cognitive models, all aimed at achieving the level of intelligence required to pass the test. Philosophical reflection. Beyond its technical impact, the Turing test spurred philosophical reflections on the nature of intelligence, consciousness, and the potential for machines to possess human like attributes. It became a focal point for interdisciplinary discussions, enriching the discourse on the intersection of artificial intelligence and philosophy. Early artificial intelligence milestones. The pursuit of the Turing test led to early milestones in artificial intelligence research. While the test itself remained challenging to pass comprehensively, the efforts to meet its criteria resulted in significant breakthroughs in natural language understanding, knowledge representation, and problem solving. Evolution of artificial intelligence paradigms. The challenges posed by the Turing test prompted researchers to explore various artificial intelligence paradigms, from rule-based systems to symbolic reasoning and later to the development of neural networks and machine learning algorithms. This evolution reflects the ongoing quest for effective approaches to achieve machine intelligence. Inspiration for public disclosure. The Turing test captured the public imagination, becoming a symbol of the potential of artificial intelligence. It entered popular culture, contributing to discussions about the future relationship between humans and intelligent machines and shaping public perceptions of artificial intelligence. Transition to practical applications. While the Turing test itself remains a challenging benchmark, the research it inspired paved the way for practical applications of artificial intelligence in various domains. The focus on achieving human like conversation capabilities laid the groundwork for advancements in natural language processing, chatbots, and virtual assistants. Legacy in artificial intelligence education. The Turing test continues to be a key topic in artificial intelligence education, serving as a case study that introduces students to the historical context, challenges, and ethical considerations in the development of intelligent systems. In summary, the enduring significance of the Turing test lies in its role as a seminal idea that shaped the trajectory of early artificial intelligence research. Its impact is evident in the motivation it provided to scientists, the milestones it spurred, and the enduring influence it maintains as a historical milestone in the evolution of artificial intelligence. The Turing test continues to be a central reference point in public discussions about artificial intelligence capabilities and serves as a benchmark for measuring progress in the field. Its enduring relevance, even in the face of acknowledged limitations, highlights its iconic status and its impact on shaping public receptions of artificial intelligence. Here are key aspects of the Turing test's continued significance in public awareness and as a benchmark. Widespread recognition. The Turing test is widely recognized outside academic and technical circles, making it a symbol of artificial intelligence in popular culture. Its mention often sparks public interest and curiosity about the capabilities and potential of intelligent machines. Cultural and media impact. The Turing test has permeated popular media, literature, and films, contributing to a cultural understanding of artificial intelligence. Its portrayal in various forms of entertainment has further solidified its status as a reference point for discussions about machine intelligence. Media coverage of AI advances. Media coverage of artificial intelligence advancements frequently refers to the Turing test as a benchmark. When reporting on breakthroughs in natural language processing, chatbots, or other AI applications, journalists often use the test as a frame of reference to convey the significance of the progress. Public perception of artificial intelligence capabilities. The Turing test shapes public perceptions of what constitutes advanced artificial intelligence capabilities. The idea that a machine could convincingly emulate human conversation remains a benchmark for many in understanding the potential sophistication of artificial intelligence systems. Mirroring human like interaction. The concept of mirroring artificial intelligence progress through human like interaction, as exemplified by the Turing test, provides an accessible metric for the public to gauge advancements in artificial intelligence. It simplifies the complex field of artificial intelligence research into a relatable benchmark. Benchmark in artificial intelligence education. The Turing test is often introduced in artificial intelligence education as a foundational concept. Students and learners encounter the test as a historical benchmark that has influenced the development and trajectory of artificial intelligence research. Reference point for ethical discussions. Discussions about the ethical implications of artificial intelligence frequently reference the Turing test. The test's emphasis on human like conversation raises ethical considerations related to transparency, accountability, and the potential for machines to deceive or mislead humans. Public engagement in artificial intelligence dialogues. The Turing test invites the public to engage in conversations about the capabilities and limitations of artificial intelligence. It prompts discussions about the essence of intelligence, the potential for machines to understand and communicate, and the ethical considerations surrounding intelligent systems. Acknowledgement of limitations. Despite its continued reference, there is an awareness of the Turing test's limitations. Critics and experts acknowledge that passing the test does not necessarily imply true understanding or consciousness, fostering a more nuanced and informed public discourse about artificial intelligence. Evolution of benchmarks. While the Turing test remains a touchstone, discussions have evolved to incorporate a broader range of benchmarks and metrics that assess artificial intelligence capabilities in specific domains. This evolution reflects a maturation in public awareness regarding the diverse applications and challenges of artificial intelligence. In conclusion, the Turing test's enduring significance in public awareness and as a benchmark showcases its role in shaping conversations about artificial intelligence capabilities, progress, and ethical considerations. Despite the evolving landscape of artificial intelligence research, the test remains a foundational concept that resonates with a broad audience, contributing to a collective understanding of the potential and complexities of artificial intelligence. The enduring legacy of the Turing test continues to fuel profound philosophical explorations that revolve around the nature of intelligence, in consciousness, and the potential for machine sentience. The thought experiment proposed by Alan Turing in 1950 has become a touchstone for discussions that transcend the technical aspects of artificial intelligence, delving into the very essence of what it means to be intelligent and conscious. Here are key dimensions of the ongoing philosophical debates influenced by the enduring legacy of the Turing test. Nature of intelligence. Philosophers engage in ongoing inquiries into the fundamental nature of intelligence, considering whether the ability to mimic human conversation, as emphasized by the Turing test, encapsulates the entirety of what intelligence entails, or if there are deeper, uncharted aspects to be explored. Consciousness and subjective experience. The Turing test prompts explorations into the relationship between machine intelligence and consciousness. Philosophers ponder whether passing the test implies a form of consciousness, self awareness, or subjective experience in machines, or if these qualities are inherently tied to biological entities. Qualia and machine experience. Debates surrounding qualia, the subjective, conscious experience of sensory perceptions, extend to discussions about machine experience. Philosophers grapple with whether machines, even if they pass the Turing test, can ever possess qualia, or if their interactions remain algorithmic and devoid of subjective awareness. Ethical considerations in AI. The Turing test raises ethical questions regarding the responsibility of creating intelligent machines. Philosophical explorations delve into the ethical implications of developing systems that may exhibit human like conversation skills, considering issues of transparency, accountability, and potential societal impacts. Machine sentience and autonomy. Philosophers contemplate the concept of machine sentience, the idea that machines, through passing the Turing test or other criteria, may exhibit a form of autonomous self-directed awareness. This exploration involves questioning the boundaries between mere computation and genuine subjective experience. Evolution of the mind. Discussions influenced by the Turing test contribute to reflections on the evolution of the mind. Philosophers consider how the development of intelligent machine may influence our understanding of cognitive process, human identity, and the co-evolution of humans and artificial entities. Alternative models of cognition. The Turing test encourages exploration of alternative models of cognition that go beyond the traditional computational paradigm. Philosophers consider whether intelligence can be fully captured by symbol manipulation, or if more nuanced biological inspired approaches are necessary. Anthropocentrism and machine attributes. Philosophers critically examine anthropocentric biases embedded in discussions influenced by the Turing test. They question whether the criteria for intelligence and consciousness are inherently human centric, and explore the potential for machines to exhibit non human like forms of cognition. Extended mind and artificial intelligence integration. The Turing test prompts reflections on the extended mind hypothesis, exploring the idea that machines may be viewed as extensions of human cognition. Philosophers consider the implications of integrating artificial intelligence into human activities and the potential transformation of cognitive boundaries. Interdisciplinary dialogues. The enduring legacy of the Turing test fosters interdisciplinary dialogues between philosophers, AI researchers, ethicists, and cognitive scientists. These conversations contribute to a richer understanding of the complex interplay between technology, cognition, and consciousness. In summary, the philosophical exploration sparked by the enduring legacy of the Turing test transcend the boundaries of AI research, inviting profound reflections on intelligence, consciousness, and the ethical dimensions of creating intelligent machines. As AI continues to advance, these philosophical debates remain integral to shaping our understanding of the evolving relationship between humans and artificial entities. In conclusion, the Turing test, despite its potential limitations as the ultimate measure of AI, holds undeniable historical and philosophical significance. As a groundbreaking thought experiment, it sparked the quest for intelligent machines and played a pivotal role in shaping early AI research. The test challenged conventional notions of intelligence, prompting scientists and philosophers to explore the boundaries of machine capabilities. The enduring impact of the Turing test is evident in its continuous simulation of discussions about the future of AI and its implications for humanity. It remains a reference point for contemplating the nature of intelligence, consciousness, and the potential emergence of machine sentience. While artificial intelligence progresses and diversifies, the test's legacy persists, serving as a reminder of the complex interplay between technology and our understanding of cognition. As the field of artificial intelligence evolves, it is likely that new and more nuanced assessment methods will emerge. These methods will not only measure artificial intelligence capabilities but also ensure alignment with societal benefits and ethical considerations. While the Turing test may eventually fade into the annals of history, the profound questions it raised will endure as fundamental elements at the heart of our ongoing exploration of artificial intelligence in navigating the future of artificial intelligence. The legacy of the Turing test will continue to guide ethical discussions and shape the trajectory of research, ensuring responsible and thoughtful